Thank you, Pierre, for inviting me. It's very nice to be in one of these workshops. I have always wanted to attend, but the Reponym series of workshops, and I think it's very good opportunity also for me to learn here. And today I'm going to talk about BITS, and maybe many of you have heard of it. BITS stands for the Brain Imaging Data Structure, which is a standard to store, organize, and share neuroimaging data. Why is it needed? Well, this can be a potential scenario in a lab. Hey, I need to ask Pedro about this old data. There's so much more we can do with it. But meet Pedro, he doesn't longer work in the lab. So professor will need a lot of help. What's the problem? The problem is that it's organized differently between institutions and even within a lab. So this produces suboptimal use of resources. Human resources, because we spend a lot of time trying to retrieve and rearrange the data. Infrastructure, because we need sometimes we have duplicates and we need many data storage space, which is very inefficient. Financial, because disorganized data has very limited value of the first publication. And on top of that, this produces this leads to very poor reproducibility of results, even within the lab where the data were collected. So a solution like BITS, which is a standard to organize and describe the data, would be very beneficial for the community. And what is BITS? BITS is just a way of organizing your data in groups that are similar, also to describe it using associated metadata. So we always know what's in there and all the details. So BITS naming convention is based on many folders, hierarchical folders and files. And we start with the subject name. Then we have the data type, which can be anatomical, which can be MEG, EEG, functional. Then the file names, which are organized following this same naming convention, which start again with the subject, then an entity defining the run or the session, and finally a suffix, which indicates the type of data that the file contains and an extension. And together with all this data, we have a sidecar JSON files, which contain all the associated metadata, which is linked to this very data that we have just shown. And it's organized in the same way, with the subject, entity, suffix, and extension. Metadata are always JSON files, which are easy to read for human and machines. And for example, this is an example of JSON file for a T1W, which contains some specific fields which are defined in BITS specification. For example, the modality, the magnetic field strength, imaging frequency. It is. So welcome to the Marie Kondo of neuroimaging data. BITS is based on 3 pillars. The first is it's the standard, BITS standard, which relates to the specification and the extensions to this specification. Then BITS tools like apps and software, and finally the BITS community. So the specification, we have just released version 1.7. And it's on the website. Here I place the link, and you can there you can access to all the details and about any modality or any field you want to check. For example, here we have a dataset description for a study, for any study, and you see there are some fields and then some requirements. For example, there are some fields that are required, like the name or a BITS version, and other fields which are recommended, and finally some optional files which are very good to have, but you can go without them. And then each field, it also has their data type, if it's a string or a Boolean or whatever, and a short description. For example, here could be a study example 1. You always will have in your directory a README TSV, a dataset description JSON file, some participants TSV and its associated JSON, and then the subjects you want to well, you have just acquired. If we start with the dataset description, it's a file like this, as we have seen. There are different fields like name, its version, acknowledgement, funding, or dataset DOI if it has. And if we go to the participants, we'll have a TSV when we have the participant ID, age, and sex, and the associated JSON file, which describes each of every category. There are some categories that are standardized like age or sex, but maybe you can add a few more columns to these TSV files, which is very good that they are described in the JSON file to know what's in there. Sometimes there are some columns that just by looking at the name, we don't know really what they mean or what are the options. So here you have to say M, it's male, F, it's female, the description, and all this, and units. And then if we have a MRI study, data should be under an AT. If we will have some fMRI, then we will have a fund folder or a WI data type. So this, again, will have the fields, the specifications that are required for an anatomical MRI, like a patient position, as we have seen, magnetic field strength, imaging frequency, and the manufacturer, if it's a Siemens machine, or the institution name. And if we have an MEG study, then the fields are equivalent, but there are some fields that are in common for all the modalities, all the data types, but there are others that are specific for MEG, like for example, power line frequency, which is very important to know the artifacts that arise at 60 or 50 hertz, depending on the country, or the reference, the DWAR position, and things like that. The main BITS specification has already merged the following BEPS. BEPS stands for BITS Extension Proposals. That means that BITS has a specification which can be extended to incorporate new modalities or new features that could be of interest for the whole community. And we extended, it initially was created at Stanford in Russ Poldrack Lab with Chris Gorgolewski and for MRI, and then many other modalities joined, and the standard was growing and growing. For example, we just merged MEG, EEG, intracranial EEG, genetic information, arterial speed labeling, very recently PET, and just in the last release, microscopy. So with associated publications, which are very soon going to be released. And this is very good news because the standard is growing across modalities, and this also facilitates neuroimaging data analysis as a whole, in the whole field. And these are the work in progress extensions, which, as you can see, there are a lot and very various, with a very strong effort on derivatives, as we will see. For now, BITS just mainly gathers the information of raw data as it comes out of the scanner. But sometimes, it's also good once you have analyzed your data that you can also standardize your results. So this is the concept of data derivatives. and each modality is working on specific derivatives specifications. And there are some common derivatives that are that can be generalized across modalities. This has been released too, so now it's time to extend. And there are other data type, other modalities like FNIRS, like by Robert Luke and Polonini, and eye tracker, and bits models. And very recently they joined a computational modeling with Petra Ritter, and many others. As you can see, there are a lot, and they are doing a lot of good progress. So soon maybe we will add another one to the new release. And in the same way as we have the specifications, we have also tools to work with bits data, because as we have seen, when you have your data standardized, it's easy to create tools that work with this data. So there are multiple tools to make it easy for researchers to incorporate bits into their current workflows and to maximize data sharing opportunities. So we have bits converters for MRI, MEG, EEG, and any new modality that gets incorporated. There are some converters that are working to get your data as it comes from the scanner to bits. There are other general tools for data querying, data plumbing operations that work both in Python and MATLAB, like PyBits and BitsMATLAB, and BitsApp, which are analysis tools like containers, as Pira has just explained, Docker containers or Singularity containers that just encapsulate an analysis pipeline and gives you some results. These are some examples of MEG and EEG converters. I come from the MEG field, so I am a bit biased towards that. But there are also equivalent for each of the modalities, for MRI and for PET. Soon, maybe we'll go for PET, but there are many converters work going on. For MEG and EEG, the main analysis toolboxes offer their own converters. Some are based on GI, and some others are based on just scripting. If there is enough time at the end of the talk, I may go to MNE-Bits, which is a MNE Python initiative by Stefan Appelhoff, which allows you to convert your data from raw to bits, in Python. And there are also, together with the converters, many bits reproducible pipelines that have just been released, where they show you how to process your data and reproduce with reproducible results. And another very important tool is your bits validator. It's the bits validator, which a good practice is always to check your bits dataset that it passed the validator. And then you can check your dataset integrity and spot missing values. And it's just as easy as well, there's a web application and also some code that you can download. This bits validator, even if it runs on the website, doesn't load your data online. So some people is afraid that they cannot share their data, they cannot put the data publicly online. But running this bits dataset runs locally in your computer, so nothing is stored on the cloud. And then it can give you some clues of what's missing, the errors you have, the warnings you have, some recommended values that you are not included, or some required ones which you are missing, which will yield to an error. And finally, the bits community. BITS is a community-led standard, which is the result of ongoing collaboration of people like you. And the specification is shared knowledge obtained after discussions and consensus that have done through the email discussion list, through shared Google Docs, and through GitHub, and in conference workshops like this, and all the information and knowledge is gathered and condensed into this concise, well, every day longer because the standard is growing and growing, but it's condensed into the specifications. And we have a GitHub repository where it contains many things like the specification, but also examples, the validator, a bits tester kit, and many tools like PyBits. And we also have a well-specified governance structure. And as I told you before, there are bits extension proposals that are called BEPs, and each of one has a leader, which takes care of it to evolve, and a group of collaborators. And the bits steering group, which was elected a few years ago, and now Ariel Rotem has just been incorporated in the place of Christy Waketeper. And as you can see, there are representation of many modalities and across the world. And we also have a super nice team of bits maintainers, and like led by Stefan, also Chris, Franklin, Remy, Taylor, Ross, Anthony, and Eric, that are dealing every day with GitHub issues and helping the specification and the GitHub repository to be online and all the extensions be aligned. Yes. So, well, any of you, if any of you wants to join the team of bits maintainers, I would really encourage you to do so. You learn a lot, and collaboration can be done at many levels. And also, if some woman would like to join, that would be awesome to have a more diverse team of people. And yeah, BITS is a very open and inclusive community, and it's done, and we have many collaborators, as you can see, across the world. And as I was saying before, you are very welcome to join and contribute. And we have a starter kit for people to just, which is new to the standard, to know where to start or how to proceed, because sometimes as it's growing, it can be seen a bit overwhelming, but there are some nice introductory points. And as I was saying, contributions can be at any levels, at all levels. You don't need to be a good programmer to join BITS, because there's like introductory things like some tutorials, documentation, more intermediate and expert. So yeah, you're very welcome to contribute. And yeah, BITS is changing the way in which neuroimaging research is done. And a global community of over 300 people created BITS standards and tools for many neuroimaging modalities, and more to come. BITS is good for future users, and also very good for future you, because if you have your data organized now, then in the future you will really be thankful for that before you forget all the details or how things were organized. And yeah, want to thank you very much and encourage you to join BITS community.